Example 12b.2, solve using matrix methods. So all we need to do is to set up the matrix as before. So we need an inverse, multiply it by the final answer, and that is going to get us our matrix. So I'm just going to write 3, 4, 2, and 3, because those are the numbers. X and Y here, that is equal to 6 and 4. Therefore, X and Y will be equal to the inverse of that. So I'm just going to clear all of this, put my inverse here. I'll get my 2 by 2, so that's 3, 4, 2, and 3. Going to find the inverse of that, and that is 3, -4, -2, and 3. Multiply it by 6 and 4. So going to highlight that across, times it by the vertical matrix of 6 and 4, and we get 2 and 0. So X equals 2, Y equals 0. Solve using matrix methods. This is example 12b.3. We've got a 3x plus 4y equals -5 plus 2z. 2x plus 3y equals 1, x plus 2y plus 3z is equal to 3. The first thing that we need to do is to make sure that all of the letter bits are on the left and only the right side should only have numbers. So in this first one, for this plus 2z, I'm going to need to put it over on here. So whenever we want to move something from one side of the equation to another, we do the opposite of what the operation there says. And so it says plus 2z here. What we actually need to do is to rewrite that first one as 3x plus 4y minus 2z is equal to -5. So all we've done is minus that, so that letter's now on the left. Now the one at the bottom is 2x plus 3y, but there's no z's. So what we're going to do is going to write plus 0z is equal to 1. And the last one is perfectly fine. So again, we're going to do the inverse of this. So we'll start by writing my first equation, which would be 3, 4, -2, 2, 3, 0, 1, 2, 3. We've got x, y, and z is equal to -5, 1, and 3. And then what I'm going to do is I'm going to then use my CAS to find the inverse. Then I just need to multiply it by the final column. So x is equal to -43, y is equal to 29, and z is equal to -4. Example 12b.4, this is from the 2007 exam. Matrices are to be used to solve the system of simultaneous linear equations, x minus 3y plus 16 equals 0, and y equals 8x minus 10. The matrix equation to solve the system is one of the following. So much like the previous example, what we need to do is make sure that all of the letters are on the left and all of the numbers are on the right. So for this first one, this x minus 3y, we've got a plus 16 sitting there on the left. We need to move that to the right. It's plus 16, so the opposite of that is going to be minus 16. So my first line should actually look like x take away 3y is equal to -16. The one at the bottom, I've got letters on the right and on the left. We're going to need to move this 8x over here. Now there's no sign at the front, so we always assume if there's no sign at the front, then it is actually a positive or a plus. So we're going to minus 8x on both sides, and we get -8x plus y is equal to -10. So that means the matrix that we would need to set this up, we'll obviously need an x and y here. We'll need a -16 and a -10. And we'll need a 1, a -3, a -8, and 1. And it looks like the only one that fulfills all of that criteria is E. The solution of the matrix equation that's shown there is one of the following. So all I would need to do is I'm just going to clear all of this business. And what I'm going to do is I'm just going to do very, very quickly, just need to go and find inverse of this and then multiply it by that final column. So I can type this all in the one statement really. So if I have this and then -1 times by the column, oops, it's too many, 1 and 9, I'll get my answer of -1 and 1, which is my answer C. Example 12b.6, which of the following systems of simultaneous linear equations have a unique solution? Unique solution means can it be solved? So in order to find out if it can or not, all we need to do is to see if our numbers can be inversed. If they can't be inversed, then there's no solution, i.e. the determinant would be equal to 0. So let's go and have a look by just setting all of these, finding out what the number bit of the matrix would be, and then find the inverse for each of those. So there are all our matrices, and all I need to do is just do the inverse of them. As soon as there's an inverse, then that will definitely have a solution. So we'll start with the first one. Okay, so there is an inverse to that 4, 2, 1, and -5. So therefore we can cross off any of the options that have discounted I. So we can get 3 sorted. Let's go and have a look at if 2 is an option. So we've got 0, 2, 1, and -2. And yes, that can have an inverse as well. So we can get rid of A, and since 2 was able to be inversed, we can actually get rid of D as well. Because that's just suggesting that 1 and 4 only, but no, we've seen that D can be as well. And then what we might do is we might see if there is 3, if the third one can as well. So 3, -12, 1 and -3, do the inverse of that, and yes, that can be inversed, so we can eliminate B, and so our answer will be E. I don't even need to check the fourth one, although for sake of completion, we'll do that as well. And there we go. That can be inversed, as you can see.